In this video, I will be doing 15 unit conversion problems. A car accelerates from rest to a speed of 108 kilometers an hour in 5 seconds. What is its acceleration in meters per second squared? We were given 108 kilometers per hour, and we want to convert them to meters per second. First, we're going to convert the kilometers to meters by multiplying by 1,000 meters every 1 kilometer. Here our kilometers will cancel, as one's on top, one's on the bottom. Then we'll convert the hours to seconds, but multiplying by 1 hour is equal to 3,600 seconds. Now solving this, we see that our kilometers cancel and leave us with meters, and our hours will cancel and leave us with seconds. This gives us 30 meters per second. Now we can calculate our acceleration. To do this, we'll use the equation of acceleration is equal to the change in velocity over the change in time. Plugging this in, our final velocity was 30 meters per second, and our initial velocity was 0 as we started from a rest. Our change in time is 5 seconds. Solving this, we get that our acceleration is equal to 6 meters per second squared. The seconds end up squared because we are dividing a fraction. This is equivalent to saying the meters per second times 1 over a second, and this is equal to meters per second squared. A force of 5 times 10 to the 3 dynes is applied to an object. If 1 newton is equal to 10 to the 5 dynes, what is the force in newtons? First, we start with our given of 5 times 10 to the 3 dynes. To convert the dynes to newtons, we have to multiply by the ratio of 1 newton is equal to 10 to the 5 dynes. Here we are dividing by numbers with exponents. This is equivalent to 5 times 10 to the 3 minus 5. This leaves us with 5 times 10 to the negative 2 newtons. A student uses 120 calories of energy while running. If a calorie is equal to 4,184 joules, how many kilojoules of energy does the student use? We were given 120 calories, and we want to convert them to kilojoules. First, we have to convert our calories to joules by multiplying by the ratio of 4,184 joules for 1 calorie. Then we can convert the joules to kilojoules by multiplying by the ratio of 1 kilojoule and 1,000 joules. Here we can see that the calories cancel and leave us with joules, and then the joules cancel and leave us with kilojoules. From this, we get that 120 calories is equivalent to 502.08 kilojoules. A ball has a momentum of 0.8 kilogram meters per second. What is the momentum in gram centimeters per second? We were given 0.80 kilogram meters per second, and we want to convert to gram centimeters per second. To do this, first we'll convert the kilograms to grams. We'll do this by multiplying by our conversion factor of 1,000 grams per 1 kilogram. Then we will convert the meters to centimeters by multiplying by our conversion factor of 100 centimeters per 1 meter. Here we can see that the kilograms cancel and leave us with grams, and the meters cancel and leave us with centimeters. Solving this, we get that 0.8 kilogram meters per second is equivalent to 8 times 10 to the 4 gram centimeters per second. A spinning wheel completes 1,800 revolutions per minute. What is its angular speed in radians per second? We were given 1,800 revs per minute, and we want to convert this to radians per second. First, we will convert the revolutions to radians by multiplying by our conversion factor of 1 revolution to 2 radians. We put 2 pi radians on top and 1 revolution on the bottom. Then we can convert our minutes to seconds by multiplying by our ratio of 1 minute is equal to 60 seconds. Here we can see that the revolutions cancel and leave us with radians, and the minutes cancel and leave us with seconds. Solving this, we get that 1800 revolutions per minute is equivalent to 60 pi radians per second. A motor produces 7.5 horsepower. If 1 horsepower is equivalent to 746 watts, how much power does the motor produce in kilowatts? We were given a motor with 7.5 horsepower, and we want to convert it to kilowatts. First, we have to convert the horsepower to watts by multiplying by our conversion factor of 746 watts per 1 horsepower. Then we can convert our watts to kilowatts by multiplying by our conversion factor of 1 kilowatt is equal to 1,000 watts. Solving this, we get that 7.5 horsepower is equivalent to 5.595 kilowatts. The density of aluminum is 2.7 grams per centimeter cubed. What is the density in kilograms per cubic meter? We were given 2.70 grams per cubic centimeter, and we want to convert this to kilograms per cubic meter. First, we can convert grams to kilograms by multiplying by our conversion factor of 1 kilogram is equal to 1,000 grams. Then we can convert the centimeters cubed to meters cubed by multiplying by our conversion factor of their 100 centimeters in a meter. Since the centimeters are cubed and our final answer is cubed, we also have to cube this conversion. Now we can see that the grams cancel and leave us with kilograms, and the centimeters cancel to leave us with meters. Solving this, we get that 2.7 grams per cubic centimeter is equivalent to 2,700 kilograms per meter cubed. A torque of 450 Newton centimeters is applied to a wrench. Express this torque in Newton meters. We were given 450 Newton centimeters. We want to convert this to Newton meters. To do this, we will convert the centimeters to meters by multiplying by our conversion factor of 1 meter is equal to 100 centimeters. Here, the centimeters cancel and leave us with meters. We can solve this to find that 450 Newton centimeters is equivalent to 4.50 Newton meters. A spring has a spring constant of 2,500 newtons per meter. If this constant were expressed in kilonewtons per centimeter, what would its value be? We were given 2,500 newtons per meter, and we want to convert this to kilonewtons per centimeter. First, we can convert the newtons to kilonewtons by multiplying by our conversion factor of 1 kilonewton is equivalent to 1,000 newtons. Then we can convert the meters to centimeters by multiplying by our conversion factor of 1 meter is equal to 100 centimeters. Here we can see that the newtons cancel and give us Newton meters, and the meters cancel and leave us with centimeters. Solving this, we get that 2,500 newtons per meter is equivalent to 0.025 kilonewtons per centimeter. A quantity z is defined by the equation z is equal to v squared over a, where v is speed and a is acceleration. If v is in meters per second and a is in meters per second squared, what are the base SI units of z? First, I'm going to write out what we were given. V is equal to meters per second, and an a is equal to meters per second squared. We can rewrite z by substituting in our units. V is equivalent to meters per second, and the quantity is squared. And a is equivalent to meters per second squared. We can rewrite meters per second quantity squared as meters squared over seconds squared. Now we can write z as meters squared over seconds squared over meters per second squared. In order to simplify the complex fraction, we we have to multiply the top and the bottom by the reciprocal of the bottom fraction. The reciprocal is equal to the bottom fraction flipped. This gives us s squared over m to multiply by the top and the bottom. This cancels out the bottom part of the fraction, leaving us with z is equal to m squared over s squared times s squared over m. Here, the second squared cancel, and dividing by m cancels the square on m. Our final answer is that z is equal to meters. If you found this video helpful, don't forget to leave a like, subscribe, and let me know in the comments what topics you'd like to see next. Thanks for watching.